Hello all. In this project, I'm going to discuss about a transit gateway, why the transit gateway is used, and how to build it. So, in this picture, if you see, right, there are I have taken like 4 VPCs. So this is the first VPC, this is the second VPC, and this is the third VPC, and this is the fourth VPC. So I have named it like a different names like call VPC. This is like a monitoring VPC. This is media VPC, and this is a database VPC. So ideally, uh, the EC2 machines which are placed in each of this VPC, right, needs to communicate with any of the machines. So for example, the EC2 machine over here wants to communicate with with the machine here. It has to communicate with the machine here. It has to communicate with machine here. Same thing with this one also. So here, here, and here. Same thing with this one. Here, so here. So now if you see, right, if you are placing as EC2 machine in each of the VPC, so either you need to create a peering connection between this VPC and this VPC, right? And again you have to create a peering connection between here and here. This is first peering connection, this is the second peering connection. Again you have to create a peering connection between this VPC and this. So this is a third VPC connection. So for each of the VPC, in order to communicate to another VPC, it has to create a VPC peering connection. So in order to avoid all these things, we will create a transit gateway. So transit gateway, you can consider it is like a router which has different kind of interfaces. So if you think of the traditional routers, right, this is like if you consider this is a Cisco router, if you consider FA0/0, FA0/1, FA0/2, FA0/3. So all are like connected interface only. So if a packet comes from here, if you want to route it to the next interface, internally it is routed because it's a router. So same concept applies here also. So this transit gateway acts as like a router with which multiple interfaces connect to it. So when your packet is arriving, it wants to reach to this destination, it will go to the transit gateway and it will route it here. But we need to configure this transit gateway. The configuration part, everything, will take it on the coming videos. So for now, we can consider this as a 4 VPCs which needs to be communicated. So for each of the VPC, I am attaching a internet gateway. As if you can see, right, in my previous videos, I have explained about the what is internet gateway, how the inbound and outbound traffic flows from internet gateway by attaching a public IP to it. Right? You can take the so for example here I have taken the all are public subnets only. If you want, you can take the private subnets also, but it will be easier thing. I have taken the public subnet, so I have taken 10.1.0, 2.0, 3.0, and 4.0. So the complete different subnets I have taken /60, 16 subnet I have taken. Okay, so let's jump into the configuration parts and we can understand it better by configuring it. So let's jump into the VPC console, and we can start creating the different kinds of VPCs now. The first VPC what we are going to create is the call VPC. Just give it as a name, and the subnet you can select as 10.1.0/16. 10.1.0.0/16. So you can click on next. So this VPC is created. Next we'll create one more VPC. This one we'll call it as a media VPC. We can give subnet as 10.2.0.0/16. You can hit on next. So till now 2 VPCs are created. So we can create one more VPC here. So this will be like a monitoring VPC. So you can give the subnet here. So you can give it as a 3.0/16. Click on next. So three VPCs are created. Now you can create one more VPC, the fourth VPC, the database VPC. Now you can give it as a 10.4.0.0/16. So total 4 VPCs we have created, and we have to create the. Now let's create the internet gateways for each of the VPC. This is for call VPC internet gateway. And you can attach the VPC to it. Make sure you'll attach in the same VPC to it. You can create one more VPC, one more internet gateway for the media VPC. Attach the media VPC. Create one more internet gateway. This is for monitoring VPC. Attach the monitoring VPC. Now the last one is like for the database internet gateway. So you create a internet gateway for database. Attach to the database VPC. Now let's create the subnets for each VPC. So we'll first select the subnets here. Create a subnet, select the VPC. For example, we'll create for the call VPC. Give it some name. You can select any of the AZ, but now we can select US East 1. And for the subnet, you have to give it as /24. So you can give it like 10.1.1.0/24. You can create a subnet. So one more subnet we are going to create. This is for the VPC, media VPC. Select the VPC here and give it some name. You can keep the AZ as the same thing, US East 1. Yeah. So this the subnet you can select is like 2.10.2.1. We can give it as 2.2.2.0. Anything you can give. Now you create one more subnet. This is for the monitoring VPC. Select the VPC monitoring. So you can keep the AC as the same thing, US East 1A, and they give you the subnet here. You can give it as 10.3.3.0/24. Now the last one is like for the database. Create subnet for this one. You can give it like 4.4.4.0/24. So now all the subnets have been created. So now you can create the route tables for each VPC. So head on to route tables, start creating route tables. The first one is like call VPC route table. Select the VPC. Select another route table. This is for the media VPC. This is for the monitoring VPC. This is for the database VPC. So all the route tables have been created. So now what we are going to do, we are going to associate the subnet to each of the VPCs. So click on the subnet here for call server. You can save association. Similarly, you select for the media. So you can select the subnet, media server, subnet and associate it. Same thing for monitoring. So same thing for the database. So now all the subnet associations have been done successfully. So now you can create the routing for this. So you can edit the route table, edit routes and add the internet route for each of the VPC. Internet route is nothing but you have to select at 0/0 and you can direct it to the internet gateway what we have created. So call VPC internet gateway, you can direct it for each VPC. We have created internet gateway, right? So the same thing we are going to update the route tables for all the VPCs. So this is for the monitoring VPC and last one is for the database VPC. So update the route here. So we have done updating the route tables for all the VPCs now. So in this video, I'm will create some security groups. So already I've created some security group. If you see, right, for call VPC, media VPC, and monitoring and database VPC I've created, and I open the ICMP inbound traffic for all of the security groups so that we can test the ping functions. Now let's start EC2 missions in all the VPCs what we have created. So let's start the missions one by one. We'll take Ubuntu missions here. We'll place it in each of the VPCs. So for example, I have created the database server for the database VPC. So we'll place this in the VPC which we created for the database. You can select the key pair, call server key pair I have already created. So that you can select, and you can select the VPC. So here I'm selecting database VPC, and subnet remains the same, and we will enable the public IP for that so that we can connect to the system. You can select the database security group for that. So you can see, right, I have created a database server in the database VPC. So call server I kept it in the call VPC. You have to launch two more systems. One is for monitoring, and is for media. So this is for again media VPC. We have to create one machine. So now that we have launched all the machines in different VPCs, you can see, right, all are running and all have the public IP. Now we'll connect one by one and we'll check whether each of them is able to ping each of them. We can open git bash here and connect with the connect command to this public IP. First we'll connect to the call server. Yeah, we are connected to the call server. If you check right, this is a 10.1.1.118. So this is the first VPC call VPC machine. Now we're trying to change the host name so that it will be easy for to identify. So let's change the host name here. We'll give it some call server so that it will be easy for us to identify which machine we are currently running the commands on. So now what we'll do, we'll try to ping all the machines from this call server. So you can try, right? From call server, I'm trying to ping 10.2.2.121. So the ping is failing. 212 is also failing. So none of the servers are able to connect to each other because we did not yet configure the transit gateway, and we have to attach all the VPCs to the transit gateway. Then it will start, each of the server can start pinging each other because the route is been formed here. Let's start creating a transit gateway. Click on transit gateway here. It will be in the VPC section. Now give it some name here. So you have to select the transit gateway ID there. And you have to select the VPC, whichever VPC you want to create the attachment, right? You can select that one and create attachment. Likewise, you have to create for other VPCs also. This is for media server VPC. Select the particular VPC for that, and you can click on next. Same thing, you have to create it for monitoring and database also. Now you have to create it for database attachment, database VPC. So now all the attachments have been created. Now we have to configure the routing. So we have to tell, right, from which subnet, how it can reach the other subnet in the another VPC through transit gateway. So we have to update the routing tables for each of the VPC now. Now you can head on to route tables. Yeah, these are the route tables, right, for each of the VPC we have created. Now we'll start updating the route tables. Just we will check the call route table, and we can give the destination network. Suppose we want to direct it to the media server, then we have to give the select the subnet, particular subnet of the media, let's say 2.0, and tell that it has to route through the particular attachment what we have given. This is a local attachment. So this is for the media subnet, and we are giving the attachment as a call server attachment. So for 2 network, for 3 network, and 4 network we have to create. This is for 3 network we have created. This is for the 4 network. So the attachment is like an interface which is being created to the transit gateway. So now that all the attachments have been made, now attachments have been created for only for VPC. We have to create it for the other VPCs also. So leaving the local network, right? We have to give the other networks because we are on 2 network. I am giving it as 1 and 3 and 4. So let's create for the monitoring VPC. So attachments for the monitoring VPC. So because monitoring VPC in the is present in the 3 subnet, we are creating a route for 1 subnet, 2 subnet, and the 4 subnet. So last thing we'll create for the database VPC, we'll update the routes because the database VPC is in the 4 subnet. We'll create for the routes for 1, 2, and 3. So at this point we have created, we have updated routes for all VPC. Now we should be able to ping from one VPC to another VPC. We can check that one. We'll start connecting to all the servers and start pinging. So you can see right now we can start ping. You can check with the first call server will ping to all of the other servers. So we are able to ping to the media subnet VPC. Even the monitoring VPC is able to ping, and also the database VPC. The same way, reverse way will also work from any of the endpoint. So that's all, folks. So we have come to an end of this project. So if you like this project, if it is useful for you in any way, please like and subscribe and share the video. Thank you.